Question number 1. Explain the meaning of differentiation and what are the techniques of differentiation. Differentiation is the process of finding the rate of change of a function. If you have a function y equal to fx and derivative dy over df has been told, we can know how fast y changes when x changes and also the slope of the graph at one point. Next, what are the techniques of differentiation? Now, there are a few common techniques we always use. Number 1, power rule. It is used when the function has the form you bring the power down and subtract 1 from the power. The formula is d over dx of x to the power of n equal n of x to the power of n minus 1. Number 2, product rule. Used when two functions are multiplied. You cannot differentiate them separately. The formula is u v prime equal u prime v plus u v prime. Number 3, quotient rule. Used when functions are divided. You cannot differentiate top and bottom separately. Formula u over v prime equal u prime v minus u v prime over v square. Number 4, chain rule. Used when there is a function inside another function. Differentiate the outside first, then multiply by the derivative of the inside. The formula is dy over dx equal f prime of g of x times g prime x, or dy over dx equal dy over du times du over dx. Number 5, implicit differentiation. There is no single implicit differentiation formula. Instead, implicit differentiation is a procedure that uses standard differentiation rules, particularly the chain rule, to find the derivative of a function that is not explicitly defined in the form y equal to fx. So we use it when x and y are mixed together and you cannot isolate y. Whenever you differentiate a term with y, you must multiply by dy over dx. For example, d over dx of y square equal 2y of dy over dx. And lastly, logarithmic differentiation. Used when a function is too complicated, especially with many multiplication or powers. Put the ln of both sides to simplify first, then differentiate. Example, y equal x to the power of x. Put ln at y and add the x to the power of x, and it will become ln y equal x ln x. Then differentiate.
For the next part, there are two questions that ask to find dy dx for both of the functions, question A and question B. So we're going to go to question A first. The function for question A, there's actually two separate functions. So in this case, we can apply the product rule to get the result of a new function from these two products. So the formula of product rule is fx times t prime x plus f prime x times tx. So the fx in this case is exponent x cubed, while the tx is sine x squared plus 3. So the f prime x and t prime x is just the differentiated version of fx and tx. So for f prime x is 3x squared, exponent is cubed, and t prime x is 2x cosine x squared plus 3. Next, we need to arrange this so it becomes like this. Then we have to simplify and rearrange it so it becomes, and that's it, that's the answer. So for question B, we're going to use the quotient rule because we are trying to find the derivative of one differentiable function divided by another differentiable function. So the formula for quotient rule is tx times f prime x minus t prime x times fx over tx powered by 2. So the fx in this question is x squared tangent 2x, and the tx is 1 plus x cubed. So for the f prime x and t prime x, we don't know that yet. So we're going to find it because the fx, there is actually two independent functions. So when that happens, we need to apply the product rule. The fx for that function is x squared, and the tx is tangent 2x. So for the f prime x, it's going to be 2x, and the t prime x is 2 secant squared 2x. We're going to arrange and simplify it, so it will become So the simplified form will be, so this is our f prime x for question B. 2x squared secant squared 2x plus 2x tangent 2x. And our g prime x is 3x squared. And then we just need to substitute the fx and gx. Don't forget the gx power of 2. After that, we need to simplify it. Final answer should look like this. And that's it.
Question 3, x squares multiplied by the exponent of 2x plus y equals sine square of 4x plus log of y cubed. Find dy dx by using implicit differentiation. First, we simplify the log y cubed and then differentiate left side and by using product rule and chain rule. Next, we differentiate the right side by using chain rule. And then we combine left and the right side. After that, we move the dy dx to the left side. Now we solve it, and we can also factor the negative 2 exponent 2x plus y.
The last question is estimate the cube root of 64.02 minus 1 over the 6 root of 64.02 correct to 4 decimal place. Step 1. Find the value that is closer to 64.02, which means 64, because it is easy to evaluate. Step 2. We calculate the value. At x equal to 64, fx we got 4. Meanwhile, gx we got 1 over 2. Then we differentiate the fx, f prime x, 1 over 3, x multiply power of negative 2 over 3, we got 1 over 48, and g prime x, negative 1 over 6, x multiplied power 6, negative 7 over 6, we got negative 1, 768. The last step, we use the linear approximation formula. Fxo plus f prime xo multiply 0.02. which is fx minus gs plus f prime x minus g prime x multiply 0.02, and we got the final answer is the 3.5004. Yay!